I should be live. I'm watching my own stream to see. But yeah, everything should be working. I'm gonna listen to myself. Yep. All right, sweet. Okay. So I don't know, I've been going through this book kind of slow. And I don't know how long it's gonna take me to finish it. Oh, gotta mute myself. I don't know how long it's gonna take me to finish it. But okay, so I was in chapter 3, and it's talking about the frequency domain, and they were given an example that let's say you have like, actually let's make the paper gridded. Gridded paper. How do I do that? There we go. Graph, whatever. So let's say you have that's good enough. You have like I'm never gonna make this perfect. What if I do this? Oh. Let's try like right here. Okay, this might be as good as I'm gonna get it. Holy cow, I don't even know how I got it. Like, it must be attaching to the, like, locking the grid. But let's say you have a point, right? Like, let's say there's the example the book says, like, let's say there's a point going anti-clockwise, and so it moves kind of like this. So like, change the color here. One point is right here, and the next point might be like right here, next point right here, and it keeps going. And the movie is 16 frames per second. I guess it doesn't really matter how many frames per second it is, but so the movie just has a dot going around the circle, and each frame has a different position of where this dot is at. Well, how do we figure out the speed of this dot? Well, I mean, you could simply figure it out. You could figure it out simply by seeing how many times it's passed this x-axis or the y-axis or whatever. Like, how many times has it passed one of these axes? Then you could figure it out, how fast it's moving. So if it passed the axis 3 times, then we knew it's 3 revolutions. Oh, well, I guess, let's say it's 16 frames per second. We have 16 frames. And we see it go past one of the axes 3 times. We know it's 3 revolutions per second then. Right? Well, that's an obvious way to figure it out, but there's another way to figure it out, which is kind of like untwisting it. So imagine, like, so this is the camera's, filming this circle and the dot going around. Imagine if you could just take the camera and spin it at the same speed of the circle. Well, if this was 16 frames per second, and we had 16 frames, and we counted that went past one of the axes, 3 times, then it should be that if we rotated this at 3 rotations per second, the dot should just stay in one spot. and it shouldn't look like the dot's moving. Yeah. And you can get a little bit more complicated than that, but it gets a little more complicated than that is what I meant to say. But also along with that, so if you were to rotate it less than 3 rotations per second, let's say you rotated it 1 rotation per second, the average of the X and the Y values, along the circle right here, let's say the radius is 1, would be 0. But if you did 3 rotations per second, the average would not be 0. I'm not sure what it would be, but it wouldn't be 0. Then if you had like a little bit more complicated shape, like I don't know if I'll even be able to draw this. Oh, I'm still on the eclipse, but whatever. That worked. I'm just gonna draw this out. It's not gonna look too great. So it would look like, let's say there was like, right? That looks kind of weird. But what this is, and I didn't draw it perfect, it's just one sine and cosine wave moving at one speed, at a large speed, and then another sine and cosine wave moving at a faster speed, which is shown by the, these little dips. But if you were to rotate, do the same thing we did with, up here, and the dot's still, moving along this line like it was before. So it's still moving slowly, throughout here, and we're taking frames of it at different points in the circle. And if we kept spinning it at so many revolutions per second, what we'd actually see is that at one point, we might, at one set of revolutions per second, we would see that, well, okay, let me explain this differently. Everywhere where the revolutions per second, the average isn't 0, is basically the frequency of one of those sine waves. So as we keep rotating it so many times per second, we're going to come across, because there's 2 different circles going on here, we're going to find 2 different points where the average might be something else other than 0. So it might be, right here. I mean, in the example they gave, it was like right here and then right here. So I figured before I even like read the questions, I mean, I know how to draw a circle in SDL, so maybe I could experiment with trying this out. I don't know if I'm going to be able to live stream this and actually like accomplish this, how well I'm going to accomplish this, but it's, it's worth a shot. I figured it'd just kind of be fun to do anyways, try to do it live, even though people don't watch me live. If anyone does watch me, it's usually if I've edited my videos afterhand, but editing takes a long time, and I don't know, I'm not really fond of video editing, and my goal isn't really to build up this channel, but I don't know. It takes too long for me to video edit stuff. And do all that jazz. So I'm just, everything that's an example, I always name test.c. It's just what I do. Learning, frequency domain. Whoa. All right. And I have like I wish I could automate this, but Windows makes things difficult to automate. So buff do no number. Oh, set no number. Buff do set no relative number. Then ignore it from the buffer list. I have a command for, I mean, a short key binding for that. So yeah, that should be fine now. Push this down a little bit. Delete that from the setup. Wait. What the freak? Oh, all right. Well, that worked. Something else I need to do. Oh yeah, I can just name this term. There we go. Now it just looks nice. So I guess the first thing would be to include STL. And I know it's gonna require STL main or whatever. Sure. Whoops. Dot win. Yeah. I think that's right. Let's see if I can make it. Well, it built it. Yeah, all right. Now I guess if I use an STL function and it doesn't work, I know that what I did didn't work. All right. So STL init. I don't know why I get these red highlights. I don't know why it's highlighting underscores all the time. It gets pretty annoying. All right, I'm back. Just had to go to the bathroom. Okay. Yeah, audio's still working. So I started working on it. What the frick? Why is it copying like... That's weird. It's like copying a ton of stuff I don't need to copy. There we go. Redefined. Oh, you know what? I think STL defines it. Or to times them by the radius. That's fine. Uh, it's not a point, it's a rect, but whatever. X, Y. Yeah, if I remember correctly. Fingers crossed. No. Oh, you know what? I probably have to... Oh, the center point. Yeah. Let's just see what this does. Plus... Well, that's cool. I don't think that's going to change anything. Hmm. That's crazy. I forget how to draw a circle. Right. Sine, cosine. Wow. Maybe I have to do a window update each time. Probably not. It's probably something I'm doing wrong. Unless I have to use the renderer. Oh, yeah, this is probably why. Yeah, makes sense. This isn't gonna look too great, but yeah, it looks terrible. That's too big a radius. See how that looks. Okay. This is, so we're on the right track. Yep, right in the corner, but let's make it try to get in the center, so it'd be what? Oh, let's make an X center and a Y center. Even better. Oh, I'm dumb. The center would be at 400, so 300 to get it in the center of the screen. No. Wait, oh. This isn't the radius, this is the diameter. No, it's the radius. Put that a little bit lower. You know, it probably is just. I'm just kind of doing this from memory. I don't know if it's right. Nah, I always forget how to do that. I think I did it in here somewhere. Oh, no. Uh, Oscilloscope. Pole event. User event dot type. Okay. No. Case. Uh, oh, did I make it true? See if that works, I guess. No. Maybe now. No. Oh, I said false again. Yeah, okay. Sweet. Oh, that's here, I think. Okay. Now we want to draw a dot certain times. So it's a little bit different than this draw circle function, but it's pretty similar. Draw spinning dot. Whoops. Every time you draw this, what did I do? Am I missing? Oh. Uh, now it's black and white. And the dot would be, it's going to be a different color. So draw spinning dot, serve. And I have no idea if it's drawing this dot. No dot. Oh, you know what? X. Well, no, that should still be right. Wait once. Oh, one thing I need to do is uh, okay. Well, we got a dot. Actually, it's 10 be 395. Yep. Should just keep incrementing I. And then whoops. Why aren't you spinning? What am I doing wrong? No? Why is this dot not moving? It's a long delay, I don't think. You know what? It's probably too small of a increment. That's a huge delay. Probably have to do it by like, try that. I don't even know if that'll work. Let's do 2 times. All right. Watch this work. Yep. There we go. But I need to clear the screen. So that means I need to do, just put this here. Woo! Try to replicate this example. Make it a little bit slower though. It's happening way too fast. It does look kind of strange when you think about it. But I believe it's doing the right thing. This is 16 frames. And if it's going at 16 frames per second, oh, here we go. We need the frequency clock. Clone. I meant clock. Something like that. Because I need to go 16 frames a second. So STL, performance, frequency. Oh, I should put FPS in here, shouldn't I? Update to FPS. There, now that function name makes more sense. And then elapsed time. All right, I'm gonna go to the bathroom again. I was still muted. I should have known I was still muted. But yeah, I got yeah, I was muted for a long time again. So this updates to a specific FPS. It's not 100% accurate, but it's close enough for the example. And this is the update function, which update to FPS uses as a callback. And then we're still drawing the circle around, drawing the dot around the circle at 16 frames a second for 16 frames. Which is why I did 2 times pi, and then I just divided it by frame count. And you just add that every single time. So this is the size of one frame. That right there. There's more to do. Now we have to rotate the whole thing. Now, how are we going to be able to rotate everything? I think what we should do is make a separate surface. And then rotate that surface. All right. Let's create a new window surface. Just make it the size of the circle. Yeah. Just keep making sure I don't actually mute. So create a circle with, surface. So the radius is 100, so width and height would be 100. No. Hmm. Should be 200. Width and the height is 200. Zero, 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 zero. Too few. 7. 1, 2, 3. 1, 2, 3, 4, 5. Oh, 32. 32-bit. Back buff. I guess I'll call it back buffer. Or back surf, I guess. Kind of a weird name. And then can I copy? Oh, just STL blit. Duh. Okay. So then STL blit surface. Source. Why is there so many recs? R1, 2. Oh, R1, it should just be 0 here. Here. Um, surf 1. Oh no, this should be back surf. Surf and R2, I think. If it draws it regularly, then it should be fine. No, it just drew a circle. Oh, no, that's what we wanted. No, wait. No, it didn't fill. I think I can just do null here, actually. Maybe it has to be a little bit wider just because yeah, it has to be a little bit bigger now that I'm thinking of it. Oh, wait. 400 is the center, so that would actually be that, I think. Oh, no, it'd be 300 to get in the center. There we go. Do I have to switch surf and back surf around? No. Then why is it not? Is it not drawing to the surface? Oh, I have to destroy the surface too. Or is it free surface? Yeah. There we go. I just make the width and the height is freaking height of the because I think that's what's causing the issue there. There we go. Now we can just put it at 0 instead of having to worry about that. There we go. But you know what? Just because I want to do it this way, let's just try putting it back to 210. Do 250 actually, just to give a little extra room. Keep that at 800 though. 250 divided by 2 is, it's 25 divided by 2. Like 12.5. No, let's just do 100 because I'm giving myself that extra 50 pixels as padding. This would be 100 minus 50, so just 50, I think. Kind of. Now I just need to fix this again. What was that? So that would be 12. No. No, I know. I'm pretty sure this is wrong, but I'm gonna try it. Yeah, it's wrong. Oh, I gave myself 50 things of padding, so it'd be like that. 50 padding. No. It's right here. 50 padding. was gonna be not good. Oh, whoops. No, oh, duck is the. Wait. 50 divided by 2 is 12. I'm stupid. Duh, why could I don't know why I couldn't figure that out. Let's do the same thing here. Oh wait, but I have to subtract 10 because of the circle size. No, 5. Duh. There we go. Finally. Put this at this isn't right. The width is 250, be 400 minus 250, which is 400 minus 200 is 200, and 200 minus 50 is 150. Now that is not right. Oh, not half of that. 800 minus divided by 2 is 400, then 400 minus 50 is 350. I feel like I'm just talking to myself, but No, it'd be 400 minus 250, I think. Four hundred minus 200 is 200, and then 200 minus 50. Yeah. Let's just see what this. All right, I have to start labeling things a little better. Because that'll make more sense if I'm reading the code. Yep. And I just thought of this. I'm probably gonna have to switch to a render if I want to rotate this surface. Yeah. Let's do rotate. Yeah. Yeah, I'm gonna have to use textures to rotate. Unless I want to do it the really complicated way. So I should have been using textures this whole time. Sorry, I can change it. I don't know why I can't figure out how to get the center. Okay, the width of this is 250. So the center point is 400, 400. The width is 250. 250 divided by 2. Yeah. Well, 25. It's like 120. No, I don't think that's right. 125. So be 400 minus 120. I feel like this isn't gonna work. No, that's it. Yeah. Which is what, 375? Four hundred minus 100 is 300. 400 minus, wait, 300 minus 25. Yeah, duh. All right. Too much stuff going on in my brain right now. It's probably the reason why I'm spazzing out or not thinking straight. So here's one surface is the window surface, and then here's another surface. But we're gonna have to change this all to using textures now. Okay. So I should have known that. Create render. STL create render. when then I need to make a texture after this. Wait, no, I can do that. So we could keep the back buffer thing. Then I could do SDL, create texture. Back buff, back serve. Yeah. Now I have a texture. Copy a portion of the texture to the current rendering. Yeah, that's what I want. So I don't forget. Then STL render copy X ren text. I just try null for now. See if that works. Fingers crossed. Again. Yeah, that worked. Except I didn't want it to be the size of the whole screen, but that means I can get rid of this stuff. Oh wait, I can take this again. Let's try this. Source rec, destination rec. Let's see what that does. Yeah, okay, that's returning it to the point we seen before. Then what is this? Is the degrees to be flipped by? This is the angle, degrees. I can convert that to radians later. Just do like a 45-degree angle. Scale point center equals 250 divided by 2. I did this a million times already. 125. There we go. All right, we got rotation. I don't remember. Let's do this. So, okay, make sure I'm not muted again. No. Turn myself up a little bit. Radians to degrees. Multiply the number of radians by pi divided by, 180 divided by pi. Okay. So uh 2 times pi what is the radius of this again? 100. Okay, so radius divided by radius times 180 then put degrees in here. See what that does. Yeah, we got radians. All right, we're slowly getting through rotating the thingy. And our goal is to make it look like this dot isn't moving. All right, I'm gonna take a break again just for a little bit because that was a lot. I'm back again. So I think I'm almost there. I'm almost there. I just need to, this is one radius. Hang on. I think, wouldn't a full rotation be, if I understand radians correctly, 2 times pi times radius? And if it is, it should just look normal. Yeah. So I'm right. If I did 2 times pi, that wouldn't be a full rotation unless the radius was 1. No. Well, I guess it doesn't matter, does it? If I did 2 times pi, 45 is what? 1, 2, an eighth? So if I want 45 degrees, I just divide this by 8. Trying to understand basic math. Yeah. Now, how are we going to get cycles per second, right? Well, we said so we want to do what? Float I equals 0, I plus equals 2 times I, kind of like what we did above. Yeah, it is exactly what we did. Yeah, exactly what we did above. Frame count. And we're just going to rotate it at the same speed. Yeah, so and whoa. So we're spinning, but we need to go. What if I did? Huh. Something's still not right though. Because the dot should be staying in the same spot if we're doing this right. Supposedly. That looks kind of cool though. It looks like we just made a sun. Um. Huh. Yeah, I thought that would work. Unless I'm not doing the calculation from multiply the number by of radians by 180 divided by pi. Oh, yes. Kind of flip vertical, flip horizontal. Let's just do both vertical and horizontal. Maybe I'm supposed to be going the opposite direction. I don't think going negative doing minus is going to go backwards, but I can try it and see what happens. Hmm. Well, I don't know. I think I'm going to be done for tonight. It's already been 2 hours. Could probably pick up the stream tomorrow.